Alright, screw this, I'm done. Alright, screw this, I'm done. So, yeah, I don't know. What the heck? Uh, I don't know why I can't seem to figure that out. It's really freaking annoying. The webcam should not be giving me this many issues, but hopefully you guys should be able to see the easy EDA screen here. So to get started, I'm just going to go through this stuff quickly and explain kind of what's going on here. Oh, man, this is really ticking me off that I can't figure out how to ever get a camera to work without being so god awful. Like like genuinely. And the funny thing is too, like it doesn't even give me a choice to like what my FPS is. It's just like, "Oh yeah, we'll just like, you know, we'll just remove your options here. Capture audio. I'll put disc. I don't know. I don't know like what the freaking deal is. It should let me change my FPS. Maybe if yeah. Yeah, it's dropping frames. We'll enable buffering. I don't know. I shouldn't. Every time I get on these like things, I want to experiment while I'm on the stream, and it's just not the place for it. So anyway, all right. So let's check on the chat here. Can everyone hear me? If anyone's wait, holy crap! There we go. All right, we're just gonna go for it. So, oops. It's not letting me drag my window. There we go. So, if we zoom out here, really it comes down to power management and um, it comes down to power management and like configuring your sensors right. To be honest, the more concerning thing to me now is power management and then just thinking of like, okay, once I get this figured out, how do I then like, scale this to um, like my actual PCB, right? So basically, we'll start down here. I don't know if I'll stick with this or not. I think I want to, but if it proves to be too complicated once I actually get into the PCB design, which good lord, I don't know when that'll be. It seems like it's never gonna happen. Um, I decided to cut it down to two pyros, and my power method here is a little interesting. It's sort of similar to what you might see on a like a telemega almost from Altus Metrum. So basically, your battery input is actually going to be in a terminal block, and then from there, like basically you'll have like your battery plug that you'll like screw down in the terminal block, the female plug, and then the male part of the battery will plug in through this terminal block area. From there, uh, from there, you'll take like a little piece of wire, and that'll also serve as like an on switch. So basically, you'll join these two contacts with a piece of wire that you screw down, and that's essentially what your on switch is. And I shouldn't say that. You have options like you can do that. I would recommend like putting a screw switch there, like just a wire from each contact of the screw switch going to there. That way you're like actually able to easily enable your rocket safely. Then we've got two power outputs here. You can see it's literally taking the straight up voltage from the battery. And then I am going to finish this up in the stream tonight, hopefully, but this is going to the like port, a pin on the actual MCU, microcontroller unit. And you can see there's a MOSFET controlling that, and we got a resistor there tying that down. We've got two power channels in case that's what you want to do. Again, this computer is being designed and, kind of like with the intention of trying to make it easy as possible for people to get into something like this. So it'd be ideal to not have to use pyros. In my opinion, pyros are honestly better. They're easier and they're more consistent. It's really hard to make a mechanical system that's like actually gonna, reliably fire and shoot under every condition. So I am kind of trying to do a mechanical thing, but there is a reason why people do so, like pyro chargers and stuff, because they work. Then heading up here, we've got a status LED. This is just a, I don't want to talk too much about an LED, but this guy, what do they call it? NeoPixel. This is a NeoPixel. And I like these guys because they're really simple to wire. Like you can see there's really not a lot going on here. And there's just so much you can do with them. So many different colors you can do with the NeoPixel. Moving up here, we have our micro USB port. I believe this is wired correctly. If we have time at the end, I'm going to verify it. But yeah, this is what it looks like as of right now. If we move over, we got a buzzer, nothing too fancy here. And then we've got our header pins. And you're probably wondering, why the heck I have three? So, at least as of right now, I want to have the ability to expand with this board a little bit if I'm, playing around. I don't want to have to reorder a million PCBs, right? So, you've got your two servos, one for each axis on the thrust vector control mount. And the third one is just in case I decide I want to screw with like some sort of mechanic servo or motor or, linear actuator, whatever type of like controlled mechanism that I might want to use potentially for like a reaction wheel or some other parachute system or air brakes or something like that. I have this here for that purpose. And you can see it's actually taking a regulated 6-volt input. And this was something that was pointed out to me on the Tripoli forum by a smart person who basically said, yeah, I think you're forgetting how electronics work. When you supply something voltage, it's going to drain. These servos, depending on which ones you're using, can be very, finicky. I am just starting with like the regular MG90 metal geared. But yeah, they really want a good 5 volts coming in. They can handle 6 volts. Technically a little more. I'm not going to send more than 6 volts, but the idea is, yeah, when these things are under load and actually, vectoring around, we want them to have a good power supply. So I'm actually feeding in 6 volts so that they're actually getting the proper power they need. So when it actually drains that voltage, it's not really realistically going to drain below 5. It'll always get what it needs. So yeah, that's enough yapping there. Just your voltage input, ground, and your pin here. I might add like a really, really low, like a 0.1 microfarad or something capacitor here at this voltage input. I'm not sure, if anybody is actually watching this who's like knows what they're doing with schematics and wiring. If you guys would recommend that I put that in here, let me know. But yeah, like probably gonna add like a really small value low pass filter capacitor or whatever they call it to maybe smoothen in that voltage that's going in here. But yeah, these are just header pins, so you'll plug your servo straight into the board. Enough talking about servos. Next, we're moving up to this guy. This is a flash chip. To be honest, yeah, I'd like to do this for the first board. My gut's almost like tempting me to just cut this board down even simpler for the first PCB. Just because this stuff is so confusing, and I want to eliminate variables of like what possibly could be screwy or going wrong. So this is a 128 flash, I believe. What is it? STM Microelectronics. I'm trying to remember who makes it. Anyways, 128 mbit, 16 megabyte flash. Correct me if I'm wrong. But yeah, this is just a regular SPI flash. It's not a QSPI, and you can see here we just got some basic stuff going on. You got our chip select pin and all of our serial clock, master out, slave in, master in, slave out, ground, and 3-volt lines. This actually I think is supposed to be grounded. I might come back and check that later. I want to say the data sheet said to ground it, but the other part of me is also like, if it was, I probably would have grounded that. Anyways, enough of that. Working our way up here. Now we have the ISM 330DHCXTR. This chip is, from the reading I've done, it's pretty good. Obviously this isn't going to be used in some higher power applications for this first board. It's just going to be used for kind of like low power and testing purposes with TVC and data measurements. So this chip is perfect for that. It can handle up to 16 Gs according to the data sheet. I'm not really going to push it more than that. This was also kind of based off the data sheet. I could be incorrect, but yeah, this is kind of what we got here. Yeah, 10Ks. I'll go back and actually verify this, but all right, moving over. So this is the MS5611. This guy is this is a baro and temp sensor. Basically, again, following the data sheet, I'm actually doing I squared C on this one as well as the other one. This guy. So I'm actually gonna pull it up here. Let's go back to the stream here real quick. So window capture. Oh wait, no. Display. That's what I want. Right? Yeah. Cool. Alright, bear with me here. Holy man. MS5611 should be this guy. No. This is, I don't even know what, I must have looked this up at some point, but. So, if we scroll down here, this is the MS5611 data sheet, and you can actually see, or no, I'm sorry. I'm thinking of the wrong thing. GUI 63 breakout board schematic. You'll see what I'm talking about here. Basically, the way I came up with this guy right here being wired this way is I looked at both the data sheet like this here. It shows you how to wire it if you're doing SPI or if you're doing I squared C. To be quite frank, I'm somebody made a comment about it in a group chat I'm in. I'm kind of tempted to just switch over to serial here. There's less going on. There's not resistors and weird stuff. It just looks simpler, and like, as stupid as it sounds, I am tempted to do it. See by the end of the stream if I get time, I might. But yeah, if you look at this is the breakout board I used on my proto board, and what you'll see is this board. If you look it up, it looks like this guy right here. You got your sensor, and then you've got, you know, the holes with the hairpins. The idea is you're able to easily wire it either SPI or I2C. And one of the things that I couldn't figure out, and I think I finally have an answer for, is what the heck are these two MOSFETs for? Originally, I thought it had something to do with if you were using SPI or like I2C, you would like auto switch between which mode you were using, so you didn't have to do some weird config thing. Basically, if you look at this schematic, this right here, pin 2, pin 2 is actually protocol select. And what that pin does is it selects the protocol, right? As the name says. So basically, if you wire it high, like it is here, to your V out from the regulator, it'll default to I2C. Now, say I pull this pin to ground, well, now it's being pulled low. Now it's going to be in SPI mode. So that's essentially how that works. I'm not actually sure if I need a resistor if I'm pulling it low. That might just be like if I'm pulling it high. I could be wrong. Anyway, back to the MOSFET story. These two MOSFETs are actually, what is it called? Phase shifting, I believe. Something like that. And essentially, it the short answer is I don't need them on this PCB because this breakout board, the GY63, advertises, now not the sensor, the data sheet, you know, this sensor needs 3.3 volts. That's why there's a regulator here, because it's putting out 3.3. What this supposedly does, these MOSFETs, unless I'm, you know, completely incorrect because I'm not an electrical engineer, but these are on your SDA and SCL lines, so here and here. And essentially what they're doing is they're making sure that those lines have 3.3 volts at all times. So if you are using a 5 volt power supply on the breakout board version of this, not the actual sensor, but like the breakout board version, if you are using a 5 volt input, it's going to ensure that you always have the proper 3.3 volts that you need on your lines. That's what it's doing. So yeah, basically, long story short, they're there to make sure that your data, while it's being transmitted on those lines, is not getting corrupted, and it's not like, you know, gonna fry your chip, basically. So that's, you know, enough of that. That's how that works. You can see there's a lot more going on in this than what I actually implemented. Like, I'm not gonna put another LED by the sensor, just because I want to save some costs on components, and this is already complicated as is. I don't need, you know, an LED for every sensor I have in front of the power input. It could help for troubleshooting, but I'm just gonna say no to it. Like, I feel like if I have a major power issue, it'll probably be noticeable by the magic white smoke. Am I right? Anyways, enough with that. Let's go back to the schematic here. Yeah, and then 6 was no connect. Cool. I wonder if it lets you edit these pins individually. No, because it's a thing. Oh, you can see here, I don't think I have it. Yeah, I think that's what pin 6 does. No, I'm so sorry. That is for this guy. This comment block here, essentially, and I actually do have it wired. The interrupt 1 pin can be used for these features below, basically. So I wired it up because that does seem pretty cool to, you know, have the ability to do. And yeah, that'll just go to a digital pin. So, and that basically we just worked all the way through pyro channels, header pins and servo functions, you know, LED, micro USB input, all that stuff, sensors, flash, whatever. That's covered. Now, the two things that I want to cover next are briefly just looking at the MCU and mainly power supply. Believe it or not, one thing I've learned from this is managing your power and getting it where it needs to go without damaging stuff is honestly probably one of the hardest things to do when you're designing a board from scratch. I thought it would be this stuff, with like, what signal wires and what go where. To be honest, like, not saying these are correct, these could be incorrect. But to be honest, power regulation is much more difficult, especially if you're doing this for the first time. So, basically, to sum up, we've got one regulator here, one regulator here, another regulator here, or I, I think it is, yeah, and then another one here. What's with the regulators? Well, basically, here's my reasoning. Uh, if any of you guys are experienced electrical engineers and you like immediately know there's like a better way to do this, please like type something in the comments because I'm willing to learn here. Like, I want to make this simpler. It looks like a rat's nest. Uh, let's let's briefly describe power on this board. What power needs to go where, and what voltages need to go where, right? So the MCU needs 3.3 volts. Standard electronics, a lot of microcontrollers need 3.3. If we're looking at our sensors here, I believe maybe this one said it could take 5, but I'm just gonna give 3.3 volts to all my sensors and my MCU. It keeps things simple, keeps our sensors happy. Um, However, one thing I have to make sure is correct with these regulator systems is that I'm actually getting a constant 3.3 even under load, because these guys are really sensitive if they're too high or too low, above above two above or two below, I guess, on the 3.3. So uh, so we need 3.3 volts, right? There's one right there. What's the next thing? Well, we need 5 volts for our servos, correct? Well, yes, but one thing, as I mentioned earlier, that was pointed out to me is under load, the voltage is going to drop while you're using the servos. So we're actually going to supply a regulated 6 volts into these servo pins here. So that way, when they're under load, they're going to, stay within the operable range. So as of right now, we've got 3.3 volts and 6 volts, right? Cool. Um, But what if I'm uploading code, right? I want to be able to power the computer with the micro USB, right? Because not only am I going to be transferring my data, but I'm also going to be transferring my power from the computer, right? So the output voltage of a regular USB port is 5 volts. So we've got also 5 volts. So how do we get these voltages? Well, the plan is, as of right now, I'm going to be using a 2-cell LiPo because I'll be able to get all the voltages I need regulated, and have enough power and current to do that stuff, right? So a 2S LiPo at full depletion is 7.4 volts because it's 2 cells, 3.7 volts each. At a fully charged, I believe it's anywhere between like 8.2 and 8.4 volts. So it's actually more than 7.4 when it's fully charged. Uh, Anyways, so we've got our 2-cell LiPo as our main input. Our 2-cell LiPo is our main input, which is 8.2 or 8.4. I think it's 8.2. And like I said, we have to regulate that 8.2 where we need it. We need 3.3 for our MCU and our sensors. We need 6 volts for our servos because that's going to change under load. And again, we also want to be able to power our microcontroller unit with a 5-volt micro USB when we're programming. So we have two power supplies. Now, we're not going to be able to drive our servos under the micro USB, technically. Um, Let me make sure that's correct. I could, okay, we've got let's see, VBAT. Oh. Oh, wait a second. I'm gonna have to check. Actually, I'm gonna check the data sheet on this guy. So, I don't know. There might be a simpler way of doing this. I just don't know how. Essentially, if we're starting up here, my thought process is here's your battery voltage input, right? Our 8.2 is coming in. We've got a 22 microfarad capacitor tied to ground, just to smoothen that voltage coming in there with that regulator a bit. And we've got this pin and this pin left unconnected, according to whatever schematic or reference thing I was looking at. A couple other capacitors, an inductor, blah 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 blah. Basically, 8.2 is coming in, and this should output 5 volts. Should, according to what the thing said. 5 volts, 3 amps should be the output of this. So from here, from the LiPo, this is, LiPo's plugged into the computer by itself, right? We now have 5 volts, 3 amps going into here, right? Well, this is a MOSFET. Hey, Doe Pickle, what's up, man? So we have 5 volts going into our MOSFET here. And, sorry, lost my train of thought. Okay, 5 volts going into MOSFET. And we've got our V-bus here. Well, V-bus is essentially the voltage of the port, like the micro USB, 5 volts. That's like if you had the micro USB plugged in and the battery plugged in, right? So the idea is, and any electrical engineers who can correct me on this, I believe this is supposed to, because basically I copied this segment here from the Feather M4's power management system, and the idea is you're supposed to be able to power the computer and upload code. Basically, you can have both. I keep stumbling here. You're basically going to be able to have both power supplies plugged in. So you can have a micro USB and your battery plugged in, and it's not going to fry the board. What it's going to do is it's going to pick the higher voltage, unless I'm wrong, and it's going to send that in as your VIN. Anyways, it's technically also, you're supposed to also be able to charge the battery from this. I don't know if I like that idea. Like, I'm at the point where, it may just be upload the code, do not plug the battery in, like, while you're uploading code or something. Something like that. Like, have it turned off. I don't know. Just don't have both supplies hooked up. That might be what I do for my first one. Because then I can actually ditch this. Unless this, like, you can do this and I'm doing it incorrectly. But I believe that's what it's supposed to do. So, your power supply from the computer is going into this regulator. It also has your battery voltage or whatever as a reference. And it's supposed to be able to charge your battery. Supposedly. It's supposed to take in your 5 volts, and it can either send it to here or charge your battery. And depending on what resistor you use, and this also was copied from the Feather M4 schematic, this guy should change the charging rate because it's changing how much current you're allowing to dump. I chose 10,000 ohms because I do not want to fry this board. I want, even if it's going to charge slowly, first of all, I don't even know if this is going to work in the first place. This could be literally, utterly, and completely wrong. But, maybe I can get away with like a 5K or 2K later on. I'm not touching that right now. Because the more current you dump, you risk frying a trace, you risk all this stuff, and it's literally impossible to test that stuff once it's fried because it's like buried in fiberglass layers. Anyway, enough of the yapping. Uh, there's also a diode going in here, making sure that you're getting a nice solid input, no backup voltages. From there, you go into the regulator, and out of the regulator, you're getting your 3.3. Finally, right? So 3.3, this guy is going to be hooked up to anything that operates on 3.3. Again, this could be a similar situation to the other stuff where, like, oh, hey, you actually need to send in like 3.5 volts or something, and because it'll, go and drain under load. I believe most of these things are actually operable still until like 2.9, 2.8 volts. And I don't think that they'll draw a lot of current and voltage because they're just sensors and stuff. But I literally know so little about this stuff, so I could be utterly wrong. Um, so yeah, finally, 3.3 is coming out. So if that's how these three work, that was my theory behind it. What am I looking at? Okay, hold on a second. We just dropped the stream. Also, you're fine, dude. Thanks for joining. I appreciate it. Oh, it looks like we're good. Um, yeah, I wish I had a camera so I could actually be like more entertaining. So, anyways, uh, we've got this fourth regulator now. So how the heck, like, what is the point of this? Uh, so going back to what I said about the servos, um, I want to make sure that I have voltage and current being regulated like well across the entire board, and I don't want stuff to affect other stuff, if that makes sense. So essentially, what I'm saying is I don't want, the current draw from the servos, to affect like the other stuff on the board, or the voltage and current draw, I should say, affecting like, operation of this other stuff, right? So if I take the, output 5 volts and I actually split it off like here, and, I make this go to my servos, I could do that, but again, with what I said about, it actually needing, 6 volts or whatever, you know, I don't think that would work. So I've actually just got a whole separate regulator here specifically for the servos. So it'll take in your input voltage and out comes 6 volts. That's literally how it works. Again, I don't know if this is correct. I based it off the data sheet. I think it is, but I don't know. So that explains the power management system. I basically wanted to be able to get 6 volts to those servos. For the pyro channels, I'm using the full battery voltage, not regulated. That was a recent change I made. And then I need to be able to get 3.3 where I need it. And um, yeah, pretty much that. So, uh, again, if you're watching this, like, if there's a simpler way of doing this, like off the top of your head, and somebody knows, please like drop an email or something and like tell me, oh hey, yeah, like you do not need all this crap. Like you can regulate voltage so much easier than this with what you're doing. Let me know. Um, anyways, that wraps up voltage regulation. Going down to the actual MCU here, this mess of stuff is honestly not as bad as it looks. This is honestly probably the easier section. To me, this stuff up here is really what I'm kind of struggling with. So you can see here we've got our some lines here for SPI stuff. Um, this stuff has to do with power management, and I basically tried to copy it off of the actual Feather M4's stuff. So this is basically the copy and pasted Feather M4 schematic stuff. and I replicated it on an actual easy EDA file import thing. So we've got a reset switch. Now that's going to go between, the reset port on here as well as ground, and it's gonna reset your computer. Shocker. There's 3.3 volts that have to go to these port lines. Why? I don't know. It's just what the feather thing did. Here are our I2C lines. We've got some digital lines coming in here for miscellaneous stuff like the interrupt pin on the sensor, the actually, what are D12 and 11 on? D12. I know 8 is for the LED. I might have just thrown those on there and not actually decided what I want to make these yet. That's probably what I did. But yeah, that's literally that's all that's going on here. Is just voltage regulation stuff and whatever. Oh, also these guys, test points. This is going to be tricky. I'm almost tempted to just like make a microcontroller and a like microcontroller and USB input only to figure this out because I've never done this before and it seems like it's hard. So, what's really annoying is when you buy a chip from the factory, it is not loaded with the bootloader. You actually have to do that yourself. What does that mean? Well, essentially, what you're doing is you're actually loading the. I kind of call it like a preliminary software almost. That's probably the complete incorrect term for this. But essentially, you have to load firmware onto the microcontroller and stuff for it to actually be like recognizable as a USB device, and even do anything with it in the first place in IDE. So you need 4 lines for that, at least from what I read. You need a reference voltage, so 3.3 volts, ground, and then these two guys here, ports 30 and 31. Those guys are your SW clock and SWDIOs. I don't even know what that means, to be honest. It just has to do with loading the bootloader, and I know that you need test points for that. So I've got those there. That is another concern for me, to be honest, because I know I'm going to need, test points or a way to get. Sorry. Yeah, I need to get those 3 things or 4 things: voltage, ground, and then those 2 lines. I need to be able to get that to get the bootloader thing to actually load the software. But I don't know how like adding a copper pad here, for instance, is going to affect regulation. Like if I add a 1.5 millimeter copper pad here to put on like a pogo pin board that I designed separate, I don't know how that's actually going to affect power regulation. Like maybe that's actually a really stupid idea. I don't know. Um, Maybe I'm completely incorrect. I also don't know. I could maybe put 2 more here, but again, that's something that I'm learning. Is it's like every little thing affects other stuff, and not being an electrical engineer makes this so much trickier because it's like your trace width, how long your traces are, depending if you have your capacitors soldered in series or in parallel, like to like traces and stuff below, or like this and this and this and this. All this stuff affects things, and you can have bad power management, and sensors not even work, not even be able to access your bootloader, and all this stuff. And it's like this stuff costs money. Like some of these chips are really cheap, but all these little MOSFETs and resistors and capacitors and things added together, like it does end up costing you a little bit, especially if you have to keep redoing it over and over because you don't know what's wrong. So that essentially covers how this guy works. I'm basically going to double check that these guys are like correct, and then I'm going to delete all this stuff here and move this over. But yeah, that's how that works. I'm gonna see if I can post this on a forum or something and have some other eyes on it and see what people think. Because, to be honest, like I feel like there's a better way to do this. My gut's telling me that this is a really stupid way of how I'm doing this right now, and believe most of it has to do with this freaking power regulation stuff. Um, maybe I'm doing too much, and I should not even try to, worry about charging the battery from the micro USB port for now, and mess with that stuff later. Maybe I don't need this other regulator. Maybe, you know, this AP212K guy can take in more than 5 volts or something. I don't know. Um, let's see. Let's look this up. It should say support fixed output. Yep. Dropout. Portable. Blah 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 blah. Input range. Oh, yeah. So I can't feed in 6 volts. It's not rated for that. Most I can go to is 5.5 going into here. So as much as I'd like to, I could do this at 5.5, but there's a chance I fry it. This guy. Huh. I don't know. The other thing too that I'm worried about, on the stock, or I'm sorry, on the Feather M4, I like I said, this is like not the stuff I added like connected, like this other regulator that's feeding into this. This was not on the Feather M4 schematic, but it did have all this stuff, right? This was all the same, except for the voltage I'm putting into the MOSFET. That was the voltage of the actual 1S LiPo, and that was not 5 volts. A 1S LiPo fully charged is like 4.2, 4.3 volts maybe. So I don't know how, me feeding in 5 volts instead of, 4.2 or whatever, I don't know how that affects stuff, to be quite frank. Um, and actually, yeah, I'm, I might be a complete idiot here. I'm not sure. Can I even charge um, a 2S LiPo with this micro USB going up to here? If that is only 5 volts, do I need my charging source to be 8.2, or do I just need the current? No, that seems like a dumb question because I feel like you can. Yeah, that's something I'm gonna have to look into later. Uh, anyways, do any of you folks have questions and stuff? Um, I know I certainly do. Let me switch to that guy. Oh, actually, let's see. Hold on. Let me. Let's see. Um. All right. Let me go back here. I'm gonna take a quick break so my brain doesn't explode. How are we doing, folks? Seems like we're doing good on drop frames right now. It's always the screen share that's fine. It's usually the freaking the camera stuff. I always have issues with the camera stuff with OBS, and I tried it. Like y'all can see what I'm talking about. All right, look at this. Look at this. I'm gonna open the camera, right? This will demonstrate like how screwed this is. I've never had this issue before. Genuinely, I've never had this issue, and it's like glitch in the matrix type stuff. Like, why is my face just like randomly twitching out? Like you would think that I'm like on something. Like, like genuinely, why is it glitching? Why? I don't get it. It like this is just my life. Like why are we glitching out, man? Why are we glitching? There's no reason. You know, it still only says it's dropping 0.2% of frames. You know, if it was that, like to me, that looks like it's dropping like 50% of the frames of me moving. So like, you know, what's going on here? Like, do you? This is annoying to me. No, it's something with the OBS. I'm telling you, I've tried a bunch of stuff. So last couple of streams that I had all those issues with, and everyone was like making fun of me because I really shouldn't have even been streaming in the first place with those issues. I should have just ended it. But the first thing I tried was seeing if I could do like a wired connection to my phone, and I couldn't get that to work. So I actually ended up like I tried this two different things. One was called like Android camera something, and the other was called like clip. No, what the heck's the name of it? Hold on, let me pull it up real quick. It's gonna kill me if I don't know what it is. I think it was like cam camo camera. That's what it's called, and that was it's called camo. Some weird application, and this like camo thing, basically you like wirelessly stream video from your phone to my computer. I think it was also streaming audio as well. Um, and you know, that was that was buggy as crap. There were times where it did actually work pretty well, and then it would just the second, like literally the second it would stop getting a connection, it would like completely disconnect, and then I'd have to go back in and like retype the IP and get it all set up again. It would not auto reconnect, which was literally annoying as shit. And so yeah, I stopped using that. Uh, or no, I think I tried another one where I did the audio from my computer and just the video from my phone, because I was like, oh, maybe I'm live transmitting too much stuff wirelessly from my phone, and that's why. And that didn't work. And then I tried a different application one night when I was doing a pyro testing um, on Ion before I sent it off to someone to work on. I think it was actually the Android thing that I tried. Or no, it was something else. I tried some other web thing, and that I don't know. It it kind of worked to an extent, but it also just like glitched out a lot. Like it dropped a bunch of frames like right when I was doing this one igniter test when I was rewashing it, and I'm like, bruh. Inbuilt Windows camera app and screen shared that window. Windows camera app. Like with my actual webcam, man. That was the other thing too. The other computer I was on was my my like personal computer, not my school one, and the webcam on that one is broken. I don't know why. It's an older Omen laptop, and it's nice, but I literally like the webcam just doesn't work on it. I tried a million things. So now I'm actually doing this on my school computer that I bought, and it does have a webcam. You guys saw it glitching out, but I mean, crap. Let's try it, I guess. But Windows camera app. What? No shot. Hold on. Let me switch to actual screen share. Let's just look up like camera. I don't know.
It looks like another app is using the camera already.
All right. Oops, did not mean to open Bamboo Studio. Let's. All right. Now this is just gonna turn into me screwing around with OBS. I swear on my life. Let's actually try. Let's do a new. Let's do window capture. And then. Yep. And then can I delete like. Display via. Is this what I'm looking for? I think I'm supposed to delete this. Oh my gosh, it's still glitching. Shocker. Remove. Yes. Cool. Oh my gosh, guess what I actually did? And then, oh, I just love it when like stuff doesn't work. All right. Oh, that does appear to be working here. Into the void, infinity windows. See if it actually lets me move my freaking. There we go. Can I have? Can I crop this? Or like, can I just go full mode or full screen on this one? Technology is like, it's a great thing, and I really don't know how to use it or design it apparently. Uh, that's annoying. Can we turn that off? Frick, how do you turn off the auto? Bruh. Settings, maybe? Video. Or just camera settings. Filming grid off. Brother, I want to turn off the flippin' auto track a face thing. Bro. I don't know. I'm not having it. Let's see. Let's go back to our chat. I'm so incompetent, I swear to God. Oh, we lost viewers. Everyone's like, wow, this guy's face is so ugly. We gotta leave. Oh, I love it when like the window that I'm not actually wanting to move just randomly moves on me. Okay. Oh, wait. camera camera try to work, challenge impossible. If I just like, can I move it out of the way? Or is this thing gonna like constantly stim out on me? Hey, you know what? That's alright. The ongoing war with OBS and the stream vibe killer continues, chat. I'm tempted to download Fortnite. Oh, let's go. I love it when my window capture just stops capturing the window. Bro, why? This is starting to piss me off, like genuinely. Oh, if I put it in barcode mode, that must be the trick, guys. Put it in barcode mode and it won't auto track my face anymore. Holy crap, guys. I figured it out. Go into Windows Camera app. Go to barcode mode. Crop the freaking screen. I gotta actually invest in camera hardware. Literally, okay. We're gonna show El Chat. This is why I don't want to post videos, because all of them are gonna suck. Because I have these crappy freaking microphones I got from Dell with my rewards points, and they look good. They looked cool, and they were like just expensive enough to the point where I thought they'd be decent, and they suck. Like genuinely. If you watch my TVC video, which also sucks, uh, any clip I have this in is horrible. Like the whole video is bad, but like any clip with this is like literally so much worse. Like I just want to chuck it. And then we've got the from KEH, the goated Canon T3 Rebel. It's like 300,000 years old. Only does like 720p video, I think. And I'd have to get like a micro HDMI and like an actual mic and stuff for it. But that costs money, so I'm never going to do that. I'm just going to keep blowing my money on rockets, which I haven't been doing that either because A, I have no money, and B, I have no money. Let's check in on chat here. Nope, don't want to save my video, I want to check on chat. Yeah, I mean, if it works, right? Okay, so, folks, here's the deal. Behind me, you can see where all of my money is now going. I don't think you can see it. Wait, can you see my big money? No, okay. So I'm investing in like a lot of tools. So some of this is also from my grandpa, that he got from the marketplace for me. We got a drill press, bench grinder, circ saw that I rewired. We've got a jigsaw, which I'm struggling to find blades for because it's so old. And we've got a circ saw that I bought. I also bought an angle grinder. This is how the tool setup's doing. Went to Harbor Freight. I got that guy for $30. This for free. Yes, literally for free. This was like $9. And there's a ton of other stuff I got. Grinding discs, all this stuff. Wire wheels, like you can see down there. OBS disconnected. I love it when that happens. Oh, God forbid I move my camera, guys. Because OBS will just shut the frick down immediately. Because, you know. Jesus, man. And the funny part is like, my Wi-Fi down here is fine. It's just I literally am like always having issues with stupid stuff like this. Uh, yeah, you can see the mess of a whiteboard I got. That's like really old. I need to erase. Um, so let's talk tools. Tools. So basically, I need them. So I've been buying them. Uh, there is like a whole freaking list that I have of stuff, and as hard as this is for me, because like to be honest, I'm kind of at a really crappy point right now. Like I'm not even gonna lie, like it feels really crappy because like usual me is like I'm constantly doing a project. I have to be doing a project, and I've got to be making progress on it. Otherwise, I just like I lose motivation, right? Like I need, even if it takes a while to get to that point, like every now and there, I need a milestone, man. Like throw me a bone, throw me a bone. That's where I'm at. And I'm at the point where like I can't do that. So yeah, it's kind of sucks because it's like I really want to do it, but I just I just can't. Basically, the reasoning is like A, money, and B, time, and C, I want to do things the right and safe way. Which actually C should be in front of the other two. Um, now, that, now that I'm saying this. Basically, what I'm getting at here is I got some, you know, as I'm getting into this more and more, like these projects get like really expensive, like really, really, really expensive and difficult and unsafe and a whole bunch of stuff. And I'm at the point where, I want to do stuff like I want to get my L3, right? That's a minimum of like 3 grand right there, minimum. But by the time, I build a rocket that, I deem as safe enough to pass a cert, which is also difficult because, for an L3, like, I'm at the point where, like, I've done some cool stuff with rockets now. I have my L1 and L2. I founded a team. We flew a freaking huge 2-stage comp rocket that I led the design and build of, and to us doing really well with. And so I'm at the point where I'm like kind of cocky about it and like, I want to send my L3 as high as possible and like show off and stuff. It's really tempting. A lot of engineers fall into the same trap and they won't admit it to you. But a lot of stuff they like overcomplicating just for the sake of overcomplicating it because they have to assert their engineering dominance, right? Because they have no physical dominance. I'm just kidding. Uh, but yeah, so I don't want to fall into that pit trap. Is it going to be complicated? Yes, it's an L3. Like, it's hard. You're putting a huge motor in there. Most of these things have anywhere from like 500 to like 1,000 pounds of thrust for like a baby M motor. Not even an N or an O. So you're putting some power in this rocket, and some money. And I really don't want to blow up a $3,000 or $4,000 rocket because I was being cocky. I want it to work. I want to take my time. Uh, so I did decide I'm not going to do a minimum diameter 4 inch like I thought I was going to. I had originally planned on doing that, minimum diameter 4 inch. I made a post about it in my Discord, and I was going to make it like 35,000, 40,000 feet for the flight, and like it's just not a good idea. The G-force. First of all, that sim ran like over Mach 3. Considering I've never done a fiberglass tip-to-tip layup with like actual sheeting. I've done fiberglass builds, but like not an actual like tip-to-tip layup with sheeting and epoxy lamination. I haven't tested the strength of that under high G's. I haven't actually done it before, so I'm not going to trust that on an L3, with an expensive engine, sending it like Mach 3 and over 23 G's is what it's sent at. So it's really risky. My other option, which I'm also tempted to do because it would be cheaper and still cool to watch, is a really big rocket. We're talking like 8-inch diameter, 15-foot tall rocket, 40-pound rocket, right? I could do that, and that's cheaper because I could do that out of cardboard. and I could again do a fiberglass sheet layout. But the the problem with that is, again, big motors, high G's. I don't know, especially if I've not done this before, how well that would fare up to a powerful M motor. Um, to be honest, I think I could do it fine. Like, it's just, again, I want to play it safe. I want to be a little bit pushy with my tech, and of course, any project I want to do, the goal is like I want to learn as much as possible. I'm not just doing it to do it. Like I want to learn stuff. So the goal with this is I want to learn stuff, but I don't want it to be so risky to the point where like I'm not going to get it back, right? So I opted for middle ground. I can't afford a big fiberglass rocket. Big cardboard rocket might not be the best idea. Minimum diameter fiberglass is cheaper but really risky, so I settled for middle ground. 5.5 fiberglass, 5.5 inch fiberglass. It's not minimum diameter. It's still gonna go high. It's gonna go like well over 2 miles, and still like over Mach 1. So it's not by any means like a baby rocket. If I put like a larger N or O motor in it, maybe I can send her like 22,000 feet plus. And this is a chunky rocket. It's not aerodynamic at all. So the fact that it can do that is quite honestly pretty cool. Um, but yeah, it's going to cost a lot. Now, for example, just the lower, half of the rocket in terms of fiberglass costs and motor mount, you're looking at $600 already right there. So there's no room to screw up. So yeah, I'm expecting it to cost a lot of money. Another thing I wanted to do is, I want to start working on experimental engine development. So making my own solid fuel. You have to start somewhere with that. I'm going to start with an existing mixture, and then I'm also working on experimental computer stuff. All the stuff that I want to do, right? It's a lot. It's way harder than anything I've done, and it takes a lot more time than anything I've done. It's hard for me to cope with. Um, and I guess what I'm getting to is I don't want to do any of this stuff incorrectly. If I try to start it now, I'm going to half-ass it. I know I will. So I am, as much as I want to do it, because it's like my itch, my craving, I'm focusing on, learning stuff, trying to meet people that know stuff, more stuff than me, and also buying the right stuff to do the job. You know, when you're working with fiberglass, it's a hard material to work with. It just straight up is. That's why you need stuff like this sitting behind me. So I've been focusing on investing all my money at this point into power tools I need. I still need band saws, belt sanders. I'm going to get a horizontal band saw like you see in the shops and stuff, like the larger ones. Might start off with the medium one. We'll see. I need a vacuum chamber for degassing epoxies and ammonia out of propellant. I need a flammables cabinet. I need a table saw. I need I need another 3D printer for crying out loud. My current setup, I got an A1 Mini and a Neptune 4 Pro. They're great machines. I like them. I got them dialed in. But I need a larger format machine. I need a machine that can do harder materials, like carbon fiber injected stuff, ABS. Both of my machines as of right now cannot do ABS. My Neptune 4 Pro claims it can. Have not had luck with it. Dimensions usually come out like crap. I don't know. I need a machine that can do it reliably. It's the key. That machine cannot do it reliably. It can technically do it. I have done it before. But very rarely do I have consistent success. Anyway, I'm going to check the comments and stop yapping. Am I able to collaborate? To be honest, dude, I don't know who I'd collaborate with. Like, at this point, I don't know. Like, there's nobody around me who does this stuff. At least locally that I know of. So, I do have my mentor, and he's always helpful with helping me figure out big problems and stuff that I have. But if you're talking like an actual collaboration, there's just not really anybody I know locally. I made a post on the Rocketry forum about potential funding because you know again I'm so novice. People can flame me all they want, but I've seen people do space shots by themselves. You know, more so university teams and stuff. Because they have department funding and sponsors and all this stuff. But people have done this by themselves, and a space shot costs like tens of thousands of dollars easily. Like easily, it costs a literal crap ton of money by the time all the engine development and testing and stuff you have to do to get certified and all this stuff. It's insane. And I've seen, there's a video out there of a guy who was like this close to the carbon on engines he developed by himself on a two-stage rocket. So basically, the post I made was like I was asking if this was something I was interested in, because honestly at this point I don't even know if I can do it or if I want to do it anymore. But how feasible is a space shot? Like funding wise, how do these people do this on their own? Like, are they doing a GoFundMe or a Kickstarter or a Patreon or something? Like, how are these guys getting their money? You can't, like, to me, I feel like there's no way these guys are like, they just have a super good job and they're able to put in like several $100,000 into a spaceship. Like, it just doesn't make sense to me. There's got to be money coming from other places. And so that was basically what my forum post was about. Was like, hey, if this is something I was wanting to do, like, does anyone know about like networking and stuff, or it could help me set up something like this? Because I figured there's no way these people are doing this by themselves. Maybe I'm completely incorrect, and people are really, really way better than me than I thought. Um, but yeah, I got utterly flamed. Yeah, everyone was extremely rude to me. It was honestly pretty hurtful because I thought I was gonna get like some help. I wasn't asking for money. Like, I wasn't like, hey, I need money right now. Like, give me money. I want to work for it. I am. But like, there's no way you guys can just like. No, it just pissed me off. The internet's rough. It's hard to get across what you want, and even technical stuff like this flight computer. This is killing me because I really want to find somebody who I can just get on a freaking video call with and show them this thing and talk to them, because there's so many questions I have, and it takes hours and hours just to talk about it. By the time I type all this out, it will take triple the time and actually convey my message. Like, it often doesn't actually come out the way you want it to. So, I don't know. I'm sticking there. It's really annoying, to be honest. I'm trying to find a mentor for electronics who can sit on a call, answer my questions. Even if I don't get everything figured out, put me on the right track. Like, that's where I'm at with this board, and just stuff in general is like, I need a godsend who can like help me on the right track. Um, and I'm waiting for it. I'm not even with. I'm looking for it. I'm searching. I'm searching hard. Um, and there's been little help here and there, but I have not gotten what I need, and it's kind of frustrating. Uh, but yeah, that's where we're at. L3 experimental engines and experimental flight computers. All stuff I want to do. All stuff that I have nowhere near the capacity of doing at this point, and I'm really losing motivation for it because it's just taken so long to get into it. And I think the other part of this like motivation rut that I'm in right now is I was able to, while I was in school, found a program, get people in this program, make significant progress, like insane progress every single day, because I was able to get access to people and money so quickly to get this stuff done. Being able to, from scratch, design and build a comp rocket in your first year in under a month in February, like, that's an insanely accelerated pace. It's impressive, and that's the type of stuff that I crave. Like, That's what I'm used to. I'm used to going full send, constantly getting work done, constantly pushing for the next thing. And, after I finish the season leading this team, right? Like, I come back home and, you know, I can't, I feel like I can't do anything, right? Like, so, yeah, it's really frustrating. Maybe this is a problem time will solve. I really hope it is because I want to get back into this. Like, I want to make some long form content, but it's like I just feel like I have nothing to make content on. Like, none of this stuff that I've done back here is really interesting enough to make like a full long video. You know, yeah, at most I've thought about making a video on this 15-footer up here, the 15-foot rocket, because that was kind of cool. But like, you know, a trillion people have done L1 and 2. You know, I'm buying tools, so what? I'm working on a computer, so what? Like, I don't know. I feel like there's nothing manifested from stuff. So it's frustrating. I thought about, maybe to get me out of the rut in the meantime, I'll start posting on my old channel. Like, I have a train that I need to restore, like a full train set. I might just post some stuff with that, but yeah, that's the current state of this whole setup. Yeah, I could make some shorts on it. I could. Man, I don't know. I've been thinking about it a lot. We'll see what comes from this. But yeah, in terms of also going back to collaboration, I technically am to an extent collaborating. The flight computer I was testing, the prototype Ion that I built and did the Pyros testing on, I actually am working with a very, very, very smart guy who goes to my university, and he's doing some firmware stuff for me, developing sensor firmware and filtering and software, or I'm sorry, yeah, telemetry UI and all this stuff for this proto computer, so that good lord, if I even get to a PCB that's finished, like I'm, I've actually got a basis for software like that. This person is a godsend. I have one godsend. Problem is, I need like two or three more godsends for me to actually feel better about myself. Um, because I've done a ton of reading, I've done a lot of research, I've been on forums, I've been on all this stuff. It's just not helping. I need somebody to teach me. That's just. I feel like that's how I learn better and quicker. I've watched YouTube videos, I've done this stuff. It helps with a lot of things. I'm not saying it doesn't, but it helps for hurdles that are this big. When your hurdles like, all the way up like the size of a mountain, like you can watch like 10 trillion crucifix videos, and like it ain't gonna do anything. You need to push up the mountain, or not even a push, because that's like expecting people to do things from you. But like, yeah, I don't know, someone to give me the climbing gear to make the climb, because that's how I kind of feel right now. Yep, that's where we're at. I have I have some other concepts in the work. You know, with the whole space shot stuff, I have a test stand concept. Again, I literally cannot do anything with this until I get the tools. I can't build a test stand until I can get a horizontal bandsaw and some stuff that I can actually precisely cut things. And then when I actually get to the point where I can build the frame on the test stand, oh, which already would cost by then like $1,000, including materials and tools. Guess what? I actually have to build the internals of the test stand, computer, test stand mount, the motor's going. I'm gonna probably have to mill a part for that because I can't 3D print a part that's gonna be able to handle between 400 and 1,000 pounds of thrust at some point. I need a load cell for said test stand. Guess how much a load cell is? Yeah, I thought it was not gonna be too expensive. I was like, oh, I'll start off with the lower capacity one. Excuse me? What? These guys are asking some insane prices for stuff, like actually. And I can't skimp out on it because if I buy a crappy load cell, I get crappy data. So like, $600 for a load cell right there. Not to mention you blow up an engine. Bye bye test stand. So So I really feel like I can do it. It's just money, contacts, and time. Which after 90 time, I know I'll make the time for stuff like this if I want to do it. It's frustrating. All right, enough of my complaining. Uh, what is going on with El Chat? What's popping, folks? I've given my updates. I've emerged from the digital void that I've been in for the past, really honestly, past year. Or no, yeah, probably since December. So past like 6 months ish. Uh, I'm hungry. I'm currently working on looking around for some engineering jobs. I've had super large success with that still. I have some good contacts that have been really helpful that I've established. I'll be great in the future. Let's see what we got in the chat. Started to work on. That's cool, man. That is cool. Oh, is this the vacuum engine? Man, how bad is my freaking stream latency? Yeah, those are cool. That reminds me of, like the Lego ones people do, right? Like the vacuum on it. That is really cool. Yeah, let's see some updates in our community chat. Our server's kind of dead. I'm almost thinking of starting a new server to be quite frank, because like um, it's poorly organized, and I don't know exactly what I'm doing with my channel still. We made an inline four. Yeah, one piston. Yeah. Again, start simple. I feel like honestly that's kind of the problem I'm having with this PCB stuff is it's too much stuff. Like I just need to dumb it down or something. I don't know. Like I'm really tempted to like cut the pyros, cut the like cut the servos, cut like the flash chip and all the stuff on there and just make like a well, no, I wouldn't be able to cut the flash. Um, but yeah, cut servos, pyros, cut like a couple of the regulators, like dual servos and other stuff, and just do like a bare bones PCB. So like just maybe even just one sensor at this point. Like I'll make a PCB for each sensor and have the MCU and just flash the or bootload the MCU, test power management because it's like too tricky to actually like narrow the problem down to where it's stemming from if I can't get other people to answer me, which is where I'm at. If I can't get people to help me out and look at the schematic and be like, oh yeah, you're stupid, do this right, the right way, like I'm just gonna have to figure it out myself because no one's really willing. I'm gonna try the electronic stack exchange because I haven't tried that yet. There might be someone there who knows more about that. Um, are you designing the engine in Onshape, right? I think so. Yeah, sweet. Yeah. Um, dude. Okay. Quick rant about Onshape. I don't know why people crap on it so much. Like that stuff's the shit. Like I like Onshape. I do. Like people can put a bounty on my head. Onshape is cool. All right. I've used SolidWorks before, and I just think it's annoying. I like. I just do. It has its place. Like, and I really need to start using it more because I could do like CFD stuff and thermal analysis and structural analysis and like actually cool stuff with it. But like but Onshape's like really easy to use for simple stuff, you know, or not even like even more complex parts. Like a lot like my L2, I designed that in Onshape because it's like I don't like it makes no difference whether I design that in 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 SolidWorks or Onshape for that build specifically. There are other stuff where like if I want to do analysis stuff, yeah, SolidWorks is better. I'll use SolidWorks when I need to do that. But this, guess what? It's CADed the same. It's gonna work either way. If I CAD it correctly, it's gonna work. Whether I CADed it in Onshape or whether I CADed it in SolidWorks, it doesn't matter as long as I CADed it correctly. No, no, I'm not gonna go out here and be like, any CAD software is gonna work. Like Tinkercad pisses me off. There are some people that are like older that are using Tinkercad that should not be using Tinkercad. That's some rage bait right there. I'm just saying Onshape gets too much crap. Same with duct tape and zip ties. You're trying to get. Every time. Oh, sweet. Okay. Yeah, man. Oh, I got it. I'm gonna change something. Switch. Yeah. Um, 3D printing is annoying as well if you have a copy machine. One thing I actually found with the Neptune 4 Pro, out of all the machines I've owned, tolerances on it are arguably the worst I've seen on 3D printers in general. I think it really, I don't know if it's like a clipper thing or a hardware thing, but tolerances are rough on that guy. Uh, like I said, it's dialed in now. Like it's fine, it works fine, it does what I need it to do. It's honestly, it's not bad at PLA, and it's okay at PETG. I've gotten it more dialed in to do PETG like semi decent. Like it's not bad at PETG. It sucks at ABS. I've like anytime I try to do like an actually large ABS print on it, doesn't work. I have messed with settings like constantly. I've had some, minor successes, but yeah, I'm talking like a machine that I can like press send and I'm gonna get a consistent print every time, and they exist. They're from Bamboo Lab. Even the Creality, even the Creality X5, like it's not a bad printer really, from what I've seen. I don't know how it does with ABS because I haven't seen a lot of people do ABS on it, but it's honestly not a terrible looking machine in terms of specs and stuff. How many folks we got watching? Two, three. I'm bored. I'm just bored now. See if I have any. Oh, here's my rant about Harbor Freight. Right, Harbor Freight and Harbor Freight and like honestly, crap. Even E Rockets is Dayton. I'm gonna have to say E Rockets is Dayton, and Harbor Freight are the two stores that like when I walk in, the the whole time I'm in there, the urge to buy something. I'm not even joking when I say this. The urge to buy something is like literally like bursting out of my seams. Like everything in there is so cool, it's so affordable. Well, relatively affordable to compared to my other options currently. Um, that I just want to buy something, which is why I, I I'm glad they're not closer to the house because I genuinely would have like $0 left instead of like two. I'm I might just end the stream. NGL. If I can figure out camera stuff the next time, I'll be happy. Yeah, I got like speaking of Harbor Freight, right? I got these angle grinder wire wheels, these two guys, plus like a wire brush, and then other wire wheel attachments for $10. $10. You go to Home Depot, one of these things is like 20 freaking dollars. Like, and they're not even like sure, some stuff is not as good quality, right? Like if you're gonna buy like an impact driver and you're gonna use it on cars and stuff, like don't go to Harbor Freight and buy an impact for $60 for that. Like just buy a Milwaukee or a DeWalt. But like for stuff like I'm doing where I don't need an impact, which actually I don't even have an impact yet, but I don't need an impact to pop off a lug nut or something crazy. Like it's fine. And then other stuff, it's nearly identical. Like a wire wheel, unless it's a complete piece of crap, like this thing, like it feels hefty quality. Like it's not a piece of crap. I wouldn't have bought it. So like, it's honestly just such a steal. I mean, even the angle grinder I got, like it's not a bad angle grinder. An angle grinder is a freaking motor and a tool, right? I got a 11,000 RPM, 7.5 amp angle grinder. It's a Bauer for $29, new, ported, new, $29. That's like a price I'd expect to see on like a marketplace list for a new tool. The freaking circ saw I got back there, 7.25 inch circ saw, $35. $35, dude. Like freaking DeWalt wants like $120 for a freaking circ saw. What's the difference? I'm not gonna be cutting a sheet of plywood like every day, every second, every day. Maybe if I do that with that saw, it's gonna fry. But like, I've used that and that already, and they work good. Like, they're actually good tools to my avail. It's shocking. I didn't think they would be. They're solid tools. All right, that's my Harbor Freight rant. Back crack time. This is only former St. Charles Robotics members will get the lore here. I bought this from Amazon. It is the infamous nylon hammer, otherwise known as Tip Tap. $15. It's probably more expensive now because I bought this like 4 years ago. Still don't need a new one. Great hammer. That's the other thing too. People don't realize this. Like genuinely, it is so much harder to be like a self-made engineer or rocketeer or anything because if you don't have somebody who's into this stuff and you've got to figure it out yourself, like you have to figure out every little detail. Like you're fully on your own. You have to figure out every little detail yourself, right? Like we had at this house, we had like one tiny little freaking toolbox with like a half missing set of Allen keys and an old Stanley hammer and like what else is in there? Like a couple of Phillips and flatheads. And that was it. Like that. Those were the only tools my house had. Like genuinely. So the fact that like either for gifts or on my own that I had to figure out what tools and what stuff I needed and buy it and whatnot. Like everything between wrenches, hammers, drills, power tools, printers, anything I needed to make something, I figured out myself. It's harder to do than most people realize because I don't just get a handful of stuff and jump into what I want to do and spend money I want to do. I have to figure out the other stuff first. But it's also much more rewarding in the end, so I do like it. Why am I flinging a hammer around? I don't know. Yep, I think it's probably time to end the stream now. Oh wait, no it isn't. No it isn't. Chat, no it isn't. You ready? Ready? Look. Look at this. Semrock. Why is this thing so freaking... Why is the exposure so bad now? Alright, anyways. Semrock Mars Lander. This thing is so intricate. You can't see because the exposure makes the thing look white. You know what I'm actually going to do? We're going to turn off the overhead. Oh, wow, that is significantly worse. No, it's not bad. Look at that. All these little pieces of paper here. Balsa stuff everywhere. This took a while. I still have to paint it. I'm proud of this. This is why older rocket kits, they're goated. Look at this. Semrock. It's not Mars Interceptor. What the frick is it? I already forgot. Oh, Scissor Wing Transport. This was an older kit. It's a remake. This is cool. Estes does not make kits this cool like this anymore. They did. They used to do a lot of stuff. It's like a plane, right? You put your engine in here, and there's a big rubber band, which I don't have on it right now. There's a rubber band that goes on here. Welcome back, by the way. There's a rubber band that goes on here, right? Engine in the bottom. And once you get to apogee and the ejection charge goes off, it shoots out this bottom piece with a streamer, which I don't have on it. This falls down. And when that piece shoots out, it pulls a little dowel out of this ring here, or out of this, what do they call them? Launch lug. Out of the launch lug, and the rubber band will flip the wing like this, and it turns into a glider and glides down. Maybe I'm freaking autistic, but this is cool. This is cool. Like, genuinely cool. I have to paint this still. It was fun to build. That was one of the things that, like, that's why I don't build a lot of smaller kits anymore, because, like, all the new ones are, like, they're so boring. It's, like, the same thing every time. Like, that's why I'd rather go to, like, E-Rockets or something like that, where I can buy, like, a vintage kit, where it's, like, even if it's not a high power thing, occasionally, I love buying something like this, where it's, like, it's cool, it's unique, it's fun to build. Alright. I'm out of ideas. Oh, I gotta add a new glue gun to my list. Alright. I don't know what happened. At some point, I had a thing get jammed in here, and I decided to pull the glue stick out, and the rubber piece that like pushes the stick in is all screwed up. So now I can't actually like use the trigger to push it in. Look at this. This would have been, holy crap! This thing's 5 years old. I feel old now. I got this for my 14th birthday from Amazon. It was a soldering kit. I think it was $12. $12. Genuinely. I can't make this shit up. $12. This tip is the same tip I've had for 5 years. I've soldered for hours on this crappy tip, and it is still tinned. It is not oxidized. What? Like, don't get me wrong. It takes forever to heat up, but it actually like somehow works. I literally don't know. But it's so funny. You don't even get a digital adjuster. Your temperature adjuster is this crappy little dial on the iron. Like, it's like the cheapest iron I've ever seen in my life. And so now it's like, I don't want to jinx it because it's probably going to be like this, the freaking time it stops working. I'm bored. Oh, see that boat back there? I gotta fix that still. Yeah. Yep. The connectors are screwed. That thing is fast as crap, though. Oh, I need to add clamps to my tool list. Now I'm thinking of it. All right, guys. Here's here's the tool list. This is like must-haves before I even start touching composite propellant stuff. I don't need all the stuff on this list for an L3, but I do need a good chunk of it. Uh, Hold on, let me add like clamps real quick, because otherwise I'll forget. Uh, Tap and die set, horizontal bandsaw, regular vertical bandsaw. I'm gonna need like a one that has a horsepower at least. I don't think I'll need more than a horsepower, but yeah, anything less than like a half, I definitely can't. Like a third is not enough for fiberglass. Um, Table saw, impact driver, stackable containers. The stackable containers we used for comp this year, genuinely, genuinely the coolest thing ever. Like you can easily unstack them. They clip together. They stay together. They roll together on this like dolly thing, and like being able to roll that stuff out to like a range in the middle of nowhere and set up a tent and then just have all of our tools and supplies in a bunch of stackable containers. It was like being in the military. Which, speaking of which, we actually had ammo cans for transporting engines. It genuinely, genuinely freaking awesome. Uh, I have Ender 5 Max on here and Century Carbon. Those are two printers I want to buy. I feel like they're good enough for what I need to do. I just need larger format and actually be able to print ABS. Hot air soldering station. I need that. Like, I need it because that's how you solder micro components. But I haven't bought it yet because I'm not going to waste my money on it if I don't actually have a PCB to solder stuff to. So I'm waiting on that. Vacuum chamber for degassing epoxies and degassing propellant. A mixer, flammable cabinet, clamps, and I have CNC on here. I'm gonna need one at some point, but to be quite frank, I don't really think I need it until I start getting into like even larger rockets where I need to actually like make my fins and stuff, as well as the engine stuff. So I don't need it now, but it would be nice later on. I actually think I need to get a new filament dehydrator, or like a big one, because mine was making a weird grinding sound. But but yeah. So enough ranting. I swear to God, I have like some insane progress plans. But I mean, honestly, as annoying as it is, like, and what I said about not making progress, it's honestly not true. Like, well, okay, it kind of is. I'm not making progress on the actual rocket stuff, or as much as I'd like to be, I should say. But I'm still making progress. Like, I have a freaking drill press sitting behind me. I didn't have that like 2 months ago. Like, this is a huge win right here. Like, this thing's actually nice too. Like, it's if you look at how long it is, it's like it's genuinely. Let me turn this freaking light back on. You've got your adjuster plate here, and just like the one in robotics, the crank handle is broken to adjust it up and down. So I actually 3D printed one to replace it, and it works great. And you can see, well, actually I don't know if you can, but it's like it's under here. Um, I cleaned it up so it looks brand new. It's old. It's like a Sears one, and you've got so many adjustments on this thing that I love. So you can change the rotation of the head, so like where it's aligned on the plate. So not only can you rotate the plate, you can actually rotate the whole freaking drill press on a pivot. You can rotate the angle of the drill, which a lot of small drill presses of like a third and of a half horsepower don't have. You can you can actually slide. Let me demonstrate what I'm talking. If you loosen this right here, you can turn this knob, and you'll see everything stays still except this whole top unit will move when I turn it. Oh wait. So, all right, you ready? Look at this. I turn it, and it adjusts where it is over the plate. I don't know why. That's like insanely cool. It also has a fair amount of speed adjustments for only being a third horsepower drill press. Like if you pop the cap open, oh wait, you can't see. Um, Basically, you move the belt up and down, and you can get 5 different speeds, and it literally has like a cool little chart in there that shows you like what uh, what speed setting you should use for certain materials and RPMs. Bruh, gnarly. I'm like, this is like easily my one of my favorite tools as of right now. And I don't know why. It's like the most basic one I have, but it's really cool. Um, I got the bench grinder still. I gotta clean up. I haven't cleaned that up. Okay, genuinely, this was in here. I don't know what I'm gonna use it for, but ouch. This was just this was just in here. It's a craftsman engraving tool. All right, you ready? Let's look. Oh, there's like brittle, stabby pieces of plastic like murdering me right now. You're gonna laugh. I've not ever used an engraving tool before. I honestly like. I really don't even know how this thing's supposed to work. I can't imagine it's too complicated. But when I tried plugging it in, this is what happened. And I don't think it's supposed to do this. Where am I? Oh wait, actually, let me plug it over here. Yeah, I have like, how many freaking outlets is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have like 10, 10 or 11 different things being powered right now off of a single outlet. But you know what? This is a convenient spot. You know why? Because look where the breaker box is. Hey, my house isn't burned down yet. I'm not. Oh, shit, that's a stupid thing to say. Uh, Engraving tool. About to engrave some rockets, I guess. I don't know what the heck I need this for, but. Oh shit, won't even turn on now. It sounds like a bomb. Like what the hell? Like it doesn't even it doesn't do anything. Like nothing moves. It just you turn it on and it just starts vibrating like all hell in my hand. It's a little sketchy. Like I feel like something's about to like explode on me, to be quite frank. Um, any video I looked up of this, the little like tip thing is supposed to like move up and down, and it does not do that. So honestly, I'm kind of tempted to like take it apart and like try to figure out. If you have a piece of metal to test it on? I think. Oh shit! Why don't I just? I don't want to do it on the drill press. Oh, actually. Oh, damn! I think I threw them away. I don't know. I have these like tiny little metal pieces that I have from the charge wells. So let's see. I'm pretty sure this is about to explode on me. Wait, am I tripping? Is it actually working? Now I'm kind of confused. Like, no, like actually. I need to look up a video of this. Okay, what if I the fuck? What if I what if I try this on a piece of wood? Something burning? trying to think what else I can test it on. I don't really have a lot. What if I just try like maybe it's working. I actually don't know. I swear to God, I looked up a video of it, and it like the little tip on the front was like moving up and down, which it isn't doing. I mean, I wrote, I wrote high. I don't know if you can see it. I need to make it bigger. This is peak boredom right here. This is like peak bum activities. I need to find like an online like night shift job. All right, I'm unplugging that piece of crap. I'm just gonna like, oh, you know what? I'm gonna start doing the. Isn't there like a girl online who like takes an angle grinder and like signs people's cars with the angle grinder and like fucks them up? Maybe I'm gonna do that. I was like, except it won't be an angle grinder, but it'll be my 30-year-old Craftsman engraving tool. I'm super bored right now. I'm so bored. I actually need to do something. I need to like work on a very involved project that I actually know what I'm doing on. Uh, so the rocket right there, completely vertical with my finger, with the white cone. That was my first rocket over 5 years ago. That's where it all began. Now I'm gonna pull my own hair out. So, I still have this ESP32 cam I gotta do something with. I might slap at my L3. ESP32 just survives 20 Gs. Uh, well, nah, no, I'm pretty sure this thing's actually broken because it says. I mean, it still kind of worked. I think the armature, something in it's bad, and the sheer vibration of it like screwing up was enough to like barely dent into it at full setting. But if you read the freaking uh, the cover card, it says 5 calibrated stroke adjustments, almost like a jigsaw, like depth and stuff. But I think it is supposed to move up and down. Jeez, man, what freaking year was this made? It says it's from Sears. It's got to be old. Like I'm thinking like late 80s, early 90s. Doesn't even say. I have no idea. We'll just say old. Uh, so guys, what away? Uh, I guess, I guess like computer, cause computer. Man, what the frick was wrong with that thing, bro? It made that my desk smell weird. I don't know. Maybe I'm frying the armature. I'm probably gonna take it apart. I might just hop off of this stream, hop onto another one on my other channel, and just take this apart. Like that's we're at like peak, like I don't know what to do right now. So okay, well, do you have any questions, folks? Specifically, or questions or criticisms? Because I love taking criticism. Dylan Core, like Dylan Vu. Wait, no, no, Dylan Vu. Oh my God, what am I saying, bro? Oh man, Luke. How did I just I just made up a person. I just made up a person. Yeah, Travado. No way I just mixed Travado and Vu together. Like, oh man, what the? No, no. I need a soundboard with like. Actually, you know what? Speaking. By the time I get to this, it's not even gonna be funny anymore. Holy shit! Where's this map? Oh, guys, I almost have it. Let me search it. Okay. Are we ready?
Los pingüinos me lo
Freak Bop's gone. It's
The Bluetooth device is connected successfully.
assembly time. Are we guessing on the other? I have no idea what you're talking about. I disassembly time on what? Goofy off. Goofy. The engraver. Oh, like 5 seconds. So I could. I don't know if you people could tell, but I am bored. All right, bet. You ready? Oh, you probably are. Uh, the HP engineer. I haven't posted anything on that channel in like 2 years. Like it's cooked. I got this close to monetization, and then, you know, posted some videos, and Google's like, "Nah, we can't let this guy get money. So we're not gonna show any of his videos." They also sucked, so I'm gonna start making some content on there, but it'll be like leisure stuff. Um, Fun fact: there are two, maybe more, but at least two videos of Mikau Sotak on that channel publicly. One of him is riding a unicycle. The other is riding a dirt bike. They left me broken Tuesday. He knows. Yes, yes. Not gonna lie, this is pretty cool. A little outdated, but yeah. To be honest, it looks really clean in here. I don't know what the freaking problem is. I might sketchy it is. I might just turn it on without the actual like spring-loaded tip, and like see if it's either like I can isolate the issue, right? If it's something wrong with this, or if it's wrong with the armature unit. Maybe a winding's bad. I wouldn't think it would be, just because of like the fact that this looks really clean and the fact that I'm dropping all the shit on the floor. Jesus. I don't understand what the point of like I don't even know. What am I looking at, bro? Like genuinely. Should I plug this in? This looks like this is gonna blow up in my hand. You know what? We're plugging it in. You know why? You only live once. That's why. Oh, it's gonna blow up in my hands, most certainly. Okay. I think it's something wrong with this. I think. I agree. I shouldn't hold any of this. Uh, it's off now. What the flip? I'm tempted to believe that it is the actual windings now. Oh God. So, hear me out. There's stuff called contact cleaner. It usually works wonders. It also catches on fire very easily when exposed to electricity. Oh, yeah, there's FRC content on there. Not much, but there is some. I don't even know, would you call this a I don't think it's a transformer. I want to say like an armature, but I don't. What am I looking at, bro? Okay, so there's like this rotational dial, right? And this dial, like, depending on where it is, it'll like change where it's positioned on the actual like the thing, right? Like where it's touching the bottom of this. So if I turn it, you'll see a gap in there now. Wait. Yeah, right there. See that gap? There's a gap in between it. Now there isn't. So maybe you could call it a transformer actually, because I feel like an armature is more like a motor. It wasn't a distinct burning cell. It was like a faint smell. It could have been burning. I just okay. Full left is like 1. I'm starting to wonder if like this freaking thing's upside down or something. What happens if I turn it on now? If I drop this on my computer, it'll most likely do something not good. I can't tell if that's like oil. Yeah. I've worked on stuff like this before. I did model train stuff. Um, like I rebuilt a lot like model train stuff. Um, but that's significantly different than this thing. I do not know what's actually wrong with this thing. Oh, wait a second. Wait, guys. I know what's wrong with it. It ain't got no gas in it. So, like, there's a piece here that's loose now. I don't know if it's supposed to do that. If I'm being honest. If I'm being honest, baby. Huh. The fact that I'm considering like getting on a forum and making a post about this and like asking what could be wrong is kind of funny. Because the reality is I'm probably never going to use this tool. Maybe like once or twice. What the frick? Oh, what? Just shocked me. Like ever so slightly. I'm gonna unplug this before I like explode the house. Yeah, that's what it's supposed to do. This like plunger here, this plunger's supposed to go up and down, but it's not, and I don't know what the frick. Like the thing's clean, it's oiled, the contact is working right. Like I have no like, I guess valid thing that's sticking out. You know, that's like this is wrong. I start looking at this. Here, yeah, I'll look into it. That's all it is. It's like supposed to move back and forth because you've got this spring plunger in here. Jeez, what
I'm
the,
about to end this man's whole career.
I don't even know what sound effect just got pressed. Uh, this plunger is spring loaded. Can I get it to move? There we go. Could be. I screwed with this thing a while ago. Just didn't have any luck with it. Yeah, this spring is like arguably pretty tight. I almost wonder if someone opened this up before and like put a tighter spring or. But yeah, it's supposed to move a plunger up and down. It's about all I know. I just know something ain't right. And I know to take it apart, they always do this stupid freaking thing with rivets with all these plates. Well, actually, I don't know. Do I need that? I might just need the, I just might need this piece. Well, no, I gotta get that off too. Yeah, I can't really get this off all the way. Unless I get this bottom piece out, which I probably could. To be honest, the only thing I can think about, or I think at this point I could be wrong, is the actual windings themselves could be screwed up. But that just would not make sense with how clean this thing looks. But for it to not be engaging like that, that's what I want to say. Take a flashlight and look down the import hole. Yeah, I cannot see literally anything down there. So, I don't know. Unless there's like supposed to be something on in here that's like broken. I suppose that could be it as well. Or no, this plunger's supposed to have a spring. I don't know. Well, folks, I'm feeling it. I think it's time. It's time to log off. The descent into stupidity has been unlike no other. No other stream before. It is time to end. So, thank you for joining. Hopefully this served as a good reference for myself as well as other people that I get involved with on this project. Um, just don't watch the end of the video when I start crashing out and losing my mind. So, alright, this is Dominic Bleacher from DHP Aerospace signing off. I wish you guys luck with all your rocket endeavors. Goodbye.